Welcome back viewers to my channel. In this video, we will discuss some numerical problems from the series and parallel combinations of resistors. The first question says like this: the total resistance of two resistors when connected in series is 5 ohm. According to the question, it says if we have two resistors of resistance R1 and R2 connected in series, then the total resistance of these resistors is 5 ohm. So we know that for series connection, Rs is equal to R1 plus R2. So in this case, instead of Rs, we will put by 5 ohm. So we will put here R1 plus R2. Say this one is equation number 1. Now, when these two resistors are connected in parallel, that's mean we have like this, then the equivalent resistance or the total resistance is 4 by 5 ohm. For parallel connection, 1 by Rp. So this one become 1 by R1 plus 1 by R2. So from here we can write 1 by Rp equal, here the LCM is R1 multiply R2, and from here we can write R2 plus R1, and this implies that Rp is equal R1 R2 divide by R2 plus R1. By given condition, this equivalent resistance for parallel connection is 4 by 5. That is Rp is equal 4 by 5. So from here we can write 4 by 5 multiply R1 plus R2 equal R1 R2. So this is 4 by 5 multiply, instead of R1 plus R2, I will put by 5. So this become R1 R2. So 5 and 5 will get cancelled. So this R1 multiply R2, it is nothing but 4 ohm. But what we want to calculate is R1 and R2. So let us use this formula, R1 minus R2 holding square. This is equal to R1 square plus R2 square minus twice R1 and R2. Now, from here we can also write R1 minus R2 holding square equal R1 square plus R2 square plus twice R1 R2 minus 4 R1 R2. So this is equal to R1 square plus R2 square plus twice R1 R2. It is nothing but R1 plus R2 holding square minus, so this one is R1 R2 minus 4 R1 R2. instead of R1 plus R2, we will put by 5, this one. And instead of R1, R2, we will put by this 4. So 4 into 4 become 16. So this implies that R1 minus R2 holding square, this is equal to 5 square is 25, then minus 16, we will get 9. So from here, it is clear that R1 minus R2 equal 3. So let us mark this one as equation number 2. From equation 1, we have R1 plus R2 equal 5 ohm. And from equation 2, we have R1 minus R2 equal 3 ohm. So if we add these two equations, then this R2 and R2 will get cancelled. So R1 plus R1 will get twice of R1. So 5 plus 3 become 8. So this implies that R1 is equal 8 by 2. So this is equal to 4 ohm. So this is the value of R1. Now, if we put the value of R1 in equation number 1, we can write 4, then plus R2. This one become 5. So this R2 is 5 minus 4. So if we take this 4 to the side, we'll get minus. So that's why minus 4. So hence R2 equal 1 ohm. So now we will solve this question number 2. The question says n identical resistors, each of resistance R, when connected in series, has an effective resistance of P ohm. Suppose we have n number of resistors, each of resistance R like this. Now, the effective resistance of this combination is P. So therefore, this can be written as an R. Let us mark this one as equation number 1. Now, if these resistance are connected in parallel, say like this, and this one is also R. So the equivalent resistance of this is Q ohm. So since these resistance now they are in parallel, so we can write 1 by Q equal 1 by R plus 1 by R plus 1 by R plus 1 by R like this, and so on. So clearly from here we can write 1 by Q is equal N divided by R. So this implies that Q equal R divided by N. So this one is equation number 2. So now multiplying 1 and equation 2, equation 1 and equation 2. So from here we can write N multiply R, then multiply R divide by N. Instead of P, I'll put an R. Instead of Q, I'll put R divided by N. So this one become P multiply Q. This N and N will get cancelled. So clearly from here, R multiply R become R square. If we want to remove that square, then we can write R is equal to root over PQ.